Welcome back to the deep dive. Today, we are taking a truly high-speed journey into a corner of astronomy that has just completely dominated the conversation.
It really has.
We're talking about the third confirmed visitor from outside our solar system, 3I Atlas, or C2025N1.
Right.
So our mission today is to try and navigate the chaos. We're going to unpack the hard, observable science, but we absolutely have to wade through the intense controversy that suggests this isn't just rock and ice.
That it's a probe or a spacecraft.
Exactly, an alien spacecraft.
And it's such a fascinating mystery. If you remember Umawa, the first one, which was so strange and cigar-shaped.
And tumbling.
And tumbling, yes.
Yeah.
And then Borisov, which was a much more, let's say, standard interstellar comet. Well, 3I Atlas is the latest one, and it brings with it data that is, frankly, it's far more perplexing than anything we've seen before.
And it was found pretty recently, right?
Very recently, July 2025, by the ATLAS survey. That's the Asteroid Terrestrial Impact Last Alert System.
And the basics are pretty straightforward, I think. It has a hyperbolic orbit,
Hmm.
meaning it's moving way too fast to get caught by the sun's gravity. It's just passing through, and now it's on its way out for good.
It's an uninvited guest, yes.
And just to reassure everyone, it already passed its perihelion, its closest point to the sun back in November. We're all safe.
Yes, Earth is fine. It's what happened during that passage that's caused this whole debate. It didn't quite play by the normal rules.
Okay, so let's start there. Let's establish the ground truth. What's the official word from, say, NASA or the European Space Agency? What is this thing?
Officially, it's an interstellar comet.
A comet.
Yes.
Mm.
That designation means they believe it's mostly ice, dust, and rock. So, chemically, it should be something like Borisov. But that classification is under siege.
And that's the key, isn't it? Because the theory that it's artificial, it's not just coming from, internet forum.
Oh, at all.
This is being driven in large part by the Harvard astronomer Avi Loeb.
The same scientist who raised all the questions about Oumuamua.
Right. And when a scientist of his stature starts publishing papers suggesting we should seriously consider an artificial origin, well, it changes the whole conversation.
It gives the idea scientific credibility. And from there, you see figures like Joe Rogan, Elon Musk.
Yeah.
They amplify it, and suddenly it's not a niche astronomical debate anymore.
It's a global phenomenon.
It exploded.
So if the mainstream says comet, what specific evidence are the people on the artificial origin side pointing to? What are the friction points?
They've really condensed their argument into 5 key observations. They call them the 5 anomalies. And these are the pillars of their argument.
Okay, so we have to go through them one by one.
We do. Because when you look at them together, they tell a surprisingly cohesive story.
All right, let's jump in. Anomaly A. This was the first thing that really raised eyebrows, right? The way it moved.
Exactly. Strange non-gravitational acceleration. As astronomers tracked it, they saw its speed and its path were changing in a way that gravity alone just couldn't explain.
It wasn't just coasting.
No. It looked like something was gently pushing it.
So if you're in the alien probe camp, that's an engine. Simple as that. It's propulsion. Active course correction.
That's the immediate interpretation, yes. But the scientific community has a very standard, well-tested explanation for this. It's called cometary outgassing.
Where the ice turns to gas.
Right. As it nears the sun, the ice sublimates, turns directly into gas, and these jets of gas shoot out, pushing the object like a tiny natural rocket.
But wait a second, we saw that with Oumuamua too, didn't we? The problem there, as I recall, was that we couldn't see a tail. We couldn't see the gas.
That was the issue with Oumuamua. With 3I Atlas, the problem is different. Its acceleration was remarkably consistent. It wasn't chaotic and random like you might expect from pockets of ice bursting.
So less like a tumbling, sputtering firework and more like a steady engine burn.
That's a good way to put it.
Okay.
The consistency of the push is what's so suspicious. Science can still model it as outgassing, maybe from one very specific stable vent, but it's an uncomfortable fit.
It's the pattern, not just the push itself. I get it. Okay, let's move to the next one, which feels like a statistical nightmare. Anomaly B, the designed orbit.
This one is just stunning.
Its path.
Yes.
Yeah.
It didn't come in at some random weird angle. Its trajectory was aligned almost perfectly with the ecliptic plane.
The flat plane where all of our planets orbit the sun.
Exactly. And not only that, its path took it on incredibly close flybys of Mars, Venus, and Jupiter.
It looks like a tour of the solar system, a pre-planned route.
It does. The proponents of the artificial theory say the odds of that happening by chance are Well, they say they're infinitesimal. They argue it was targeted for reconnaissance.
And the Jupiter flyby is a big part of that, isn't it? The idea of using its gravity, the Hill sphere.
The Hill sphere, yes. That's the zone around a planet where its gravity is dominant over the sun's.
Yeah.
Using Jupiter's huge Hill sphere for gravity assist or to deploy smaller probes, that's classic planetary science is what we would do.
So what does mainstream science say? That it was just a lucky shot?
Essentially, yes. They argue that while it's incredibly rare, the galaxy is enormous. With billions upon billions of objects flying around, eventually one is going to hit the statistical jackpot.
That feels like a bit of a hand wave, though. Anything can happen given enough time.
It does feel that way to some. It certainly challenges what we consider a random encounter. But let's move on, because Anomaly C deals with what the thing is actually made of.
The anomalous metal composition.
Right. This is where physical evidence seems to really clash with the icy snowball idea.
What did the spectral analysis find?
When they analyzed the gas cloud around it, the coma, they found unusually high amounts of nickel.
Okay.
But it wasn't just the presence of nickel. It was the ratios of the elements. They looked a lot more like industrial alloys than what you find in a natural rock.
Wait, what does that even mean? You're saying the metal in its gas cloud looked man-made or alien-made?
That's the implication. Natural objects like meteorites have a kind of primordial, well-mixed recipe of elements. An industrial alloy is different. It's processed. You pick specific ratios of, say, nickel and iron to get strength or heat resistance for building a hull.
And the data from 3 Atlas look like that?
The data suggested those kinds of specific, non-natural ratios. The implication is pretty direct. You're not looking at a rock, you're looking at a piece of machinery. A hull, maybe, that's shedding material.
Wow. Okay. That's a powerful piece of evidence. Let's shift to the one that sounds the most like a spy movie. Anomaly D.
The hiding maneuver.
This one is almost comical. At its closest approach to the sun, the most critical time for us to observe it.
It went right behind the sun, from our point of view. It completely blocked our view for a crucial period.
And the theory is that this was deliberate, that it
Yeah.
used the sun as a shield to hide what it was doing.
Exactly, to hide something like an Oberth maneuver.
Can you explain that for our listeners? An Oberth maneuver.
It's the most efficient way to use a rocket engine. You fire your engine when you're moving at your fastest, deep inside a gravity well like right next to the sun. Doing that gives you a massive boost in kinetic energy. It's the best bang for your buck, fuel-wise.
So if you wanted to get out of the solar system as fast as possible, you do it there. And if you didn't want anyone to see you fire your engine,
You do it while hiding behind the star. It implies intent. Cunning, even.
it really does. Okay, finally, Anomaly E. Unusual brightness and color. Did it just look weird?
It did. It was brighter than our models predicted for an object its size, and at certain points it gave off a distinct blue hue.
And for the artificial theory, blue is a very suggestive color.
It is. They propose it could be artificial lighting, or maybe the glow from a high-temperature exhaust plume. Certain kinds of high-energy propulsion could, in theory, produce a blue signature.
What's the natural explanation? Can comets be blue?
They can, yes. It's rare, but certain chemical reactions can do it. Gas, like molecular carbon, when it gets sacked by solar radiation, can fluoresce with a blue-green light.
But
But the intensity and the persistence of the blue from 3I Atlas were, again, unusual, even for a chemically weird comet.
so if we step back for a second, we have 5 anomalies. Each one, you could say, can be explained away with a slightly stretched, it's just a weird comet theory.
Right. A unique outgassing vent, a 1 in a billion orbit, a rare chemical mix.
But when you string them all together, the consistent push, the perfect tour guide orbit, the industrial metals, the hiding, the blue glow, they paint a very different picture.
A picture of a targeted reconnaissance probe. That's the tension. That's the heart of this entire controversy.
So where does that leave us with all this public debate? Where do the big institutions like NASA and SETI actually stand right now?
The consensus remains chemically peculiar interstellar comet.
Still a comet.
Still a comet. You have to understand, the burden of proof for claiming extraterrestrial technology is, it's impossibly high. Extraordinary claims require extraordinary evidence.
And what's their strongest evidence against the artificial theory? What are they pointing to?
2 main things. First, observationally, we did get some images, and it showed a distinct, dusty cometary tail and gas eruptions.
Which a sleek, efficient spaceship probably wouldn't have.
You wouldn't think so, no.
Yeah.
You'd expect something non-emissive, clean. Second, and this is the big one, the silence.
No radio signals.
0. SETI did a thorough search. If it's a functioning probe, you'd expect it to be transmitting data or at least receiving commands. We heard nothing. The silence is deafening.
No radio chatter, no one home, at least nothing we can detect.
And for now, that's the deciding factor. 3I Atlas is sailing away, leaving us with this mountain of wonderfully ambiguous data.
So to wrap this up, it's a truly bizarre visitor, one whose steady acceleration, its aligned orbit, its industrial-looking chemistry, all of it has basically guaranteed its place in astronomical controversy forever.
That's exactly how it will be recorded. Not as an alien ship, but as the most suspicious natural celestial body we have ever observed. Unless, of course, future analysis of the data we collected finds something undeniable.
Like a non-natural radio wave hidden in the noise.
Precisely. But until that happens, it's just a very, very strange comet.
It really forces science to confront the very edge of what natural can mean. And it leaves you with this final thought. If 3I Atlas really is just a natural comet, and it hit this statistically infinitesimal alignment by chance, well, just how common must these mind-boggling, seemingly impossible cosmic events be across the galaxy? It raises the bar for what we consider normal, and it makes you wonder what else is just silently passing by.